Hello, everyone. Welcome back to the fourth lecture. In this lecture, we're going to start building our models and train the model and perform the prediction. And then we also want to evaluate the training result, the training performance. So first we want to do is, as we described before, the data set we're going to use, we're using, and we're going to split it into two parts. One called the training, the other part called testing. So we're going to train our model using the training data set, and then we're going to validate our model performance based on the testing data set. So see if the testing data set can also well predicted by the model. So let's do the first thing we call the training test split. So instead of using the test data set provided in the CSV file, I'm going to perform a regular process. I'm just going to assume the training set we are using for now is the entire data set, how to split it into two parts. So first I'm going to load a library from sklearn and model selection, and we want to import the training and test split. Okay, that's our part. And next thing's what we're trying to do. We're going to split our models, split our data into the X-trend and X-test, and Y-trend and Y-test. Using the training split, okay. And what we're going to using for the training part, and the X part is the feature part, and should not including the so-called our response variable, the target we call the survive portion. So I'm going to drop the survivor column, okay. Drop the survivor column, and using AX, X equal to 1. So drop the survive column, and then the Y column is Y part is going to be only the survive column. All right. So column. So the first part X is not including the survive column, and the Y, which is a response variable, only include the survive column. And test size, let's do that. Test size, I'm going to let it equals to 30%, which is about 70-30 split, okay. And then we're going to do random stay equals to 103, for example. Okay, so this is representing our part. So let's do this. So training that part was dropping the survival column, and the rest of them going to the X. The Y part actually only including the survive column. I'm doing a 30-70 split between the training set and so after we've done that, and we should be able to build our model. Again, from the sklearn, Okay, and I'm going to import the logistic regression. Logistic regression portion. So I'm going to load the logistic regression portion. And I'm going to call it logics model equals to the logistic regression part. Okay, so this is the model class I'm going to define. I'm going to screw it up a little bit so you can see a little bit better. So we build a model first. So here we build a logistic regression object class. Okay, and then the next we're going to do the fit, which is fit the model based on the training data set and of the X and also the Y training data set. All right, so this is the part actually just define the model, logistic regression model, and here we're trying to fit the model using training data set. Okay, and that's it. That's all there is to it. So, okay, import the linear models, logistic regression, and define the model. This is solving the model for now, and then we can see the prediction right now. So I'm going to using predict y value, and I'm going to call it y predict equals to the model we just trained. Okay, called predict using the X test model. So here I'm going to using the X test, the testing data set, to have the model predict, and we'll call that Y predict. The next thing what we're going to do is when trying to compare the Y predict with the Y test, which is the original. So again, from the sklearn, we're going to matrix and import the classification, report. All right, and then we're going to print the report. Based on the Y test, which is the original input for the Y, and compared it with the Y predicted. Okay, now we see that. So we get a pretty decent prediction on this. Its total is about 79 to 80% total accuracy and 79% of accuracy. This is what we come up with. Let's review the whole thing one more time. Building the logistic regression model. What we can do is including the model selection, okay, first, and import the training test split and split the dataset train by everything except the survive column, and the Y will be only the survive column, using a 30-70 split, okay, and giving a random see how they select. So among all these 890 passenger, I'm going to choose 70% for training, 30% uh, for testing later on. Then we build a model. We import the linear regression model. Okay, linear regression model. Logistic regression model, I'm sorry. And build a model and train the model using the training data set X train, Y train. And then we perform a prediction, okay, on the X testing data set of the feature portion and getting a Y prediction. Then we're using classification report to compare the differences between the Y test and the Y prediction data. So this is pretty much, we're going to follow the similar process for the next couple machine learning algorithm we have. The sklearn, they formulate all these different machine learning algorithms, especially in classification, using a very similar workflow. And this is a workflow we're going to repeat a couple times. And then we see how that goes. Okay, next thing what I want to do, I want to show you the so-called confusion matrix as well. So I'm going to import a confusion matrix as well. This portion, confusion matrix. So once I print up the classification report, I can also print the confusion matrix report. I'm going to using Y set compared to the Y predict, print the confusion matrix in that regard. It shows me actually actually 150 of those we predict correctly, and which is the non-survival, and 62 are predicted correctly in the testing data set as a survival, and actually 18 of them actually they didn't survive. We predict they survive, and there is the 37 of them actually survive. The model predict them are not surviving. So this is the so-called confusion matrix, and the the false positive in the 37 false positive, and 18 of them false negative. So these are the conclusion for this particular session. We're going to talk about some other machine learning algorithm later on. Finally, final comments we have. We still have a way to improve this model. For example, we grabbing their last name or where they're coming from. Using the cabinet information, we can do more features, and maybe we can improve a little bit the model prediction. This is a very simple process of prediction. You can see that other than the test training split portion, actually the modeling plus the prediction is only 3 lines of code. If you're including this test training split, is probably only 5 different lines. And to evaluate your prediction compared to the test data, it takes 2-3 more lines. So the modeling and fitting itself is fairly easy. However, for actually, this is pretty much the data scientist's job. You spend about 90% of your effort on massage the data, putting the data into a format you can train the model. And this is part of the process we'll call the exploratory data analysis, and also by changing cleaning some of the categorical data from string information into the numerical information is what we call the feature engineering. And these type of things are cost you 90% of your effort. And I'm sure you can also experience that in some of our homework and even our midterm exam. But these I want to illustrate, you spend majority of your time on data massage, explore the data portion, and training the technical part and fitting your models and predicting your models actually very straightforward. So this concludes this part of our lecture.